In this section, we're going to have a look at the vector equation of a line. So imagine we have a straight line here, which passes through a point A here, which has a position vector of A, if this is the origin. And that this line here is parallel to another vector, which we'll call vector B. So we can see that R, if we put R anywhere on this line, it will be parallel to B. So even if I put it up here, we can still, wherever I put it on this line, it's parallel to vector B. We can find this point, or any point on this line, by starting at the origin and going up through vector A to get onto the line, and then going some distance along this line. So we should be able to recognize that this will be a scalar multiple of vector B. And wherever I go on here, I can do the same thing. Start at the origin, go up through position vector A, and then I go along some multiple of vector B. Even if it's up here, it would obviously be a negative scalar multiple of vector B because it's going in the opposite direction. But I could still find it. So this resultant vector, OR, we can, wherever it is, express as OA plus AR. Now obviously if it was up here, then this would be negative. But we can simplify that then as vector A plus T, some scalar multiple of vector B. And indeed that could be negative if it was up here. But we call this, this number here the parameter. So that's the formal definition for the vector equation of a line, given by R equals A plus TB, where T is the parameter. So let's have a look at how we can actually get to grips with this through an example. So we're asked to find the vector equation of the line through the point 1, negative 1, 3, and parallel to the vector negative 1, 3, negative 1. We're asked to find the vector equation of the line through the points A and B here, and in C we're asked to find the acute angle between these two lines. So if you think you can have a go at attacking these questions, do, otherwise you might just want to follow through with me. So in the first instance, we need to figure out what the two vectors are. So we said vector A is going to be, if we express it using unit vectors, it's going to be 1i minus 1j plus 3k, and B is already in this form, so it's negative 1i plus 3j minus k. So the vector equation of the line, quite straightforwardly, first of all we've got to get up onto the line. We know it goes through this point, so we express the position vector here, and then we know that we're going to be going some component or going along in some direction parallel to this vector here. So here's the direction vector, and we've got the parameter t here. So that is the vector equation of the line. For part B, find the vector equation of the line through the points A and B. So here we're going to need to recognize that if we know it goes through the point A, we can express OA as 1, 0, negative 4, and if it goes through B as well, we can express OB as negative 2, 1, 1. Now, because it goes through both of these points, in this instance, we can find the vector AB through rearranging the equations. So AB would be vector OB minus vector OA. So vector AB is going to give us negative 3, 1, 5. So this is actually the direction vector. Okay. So in this instance, we're told that the line goes through 2 points. So to find out, to get onto the line in the first instance, we're going to take the position vector of vector A, so 1, 0, negative 4, that should be fairly straightforward. And then we're going to need to go some distance along a line parallel to vector AB. So we found vector AB here, which is negative 3, 1, 5, and then we're going to put the parameter t here. Finally, in part C, find the acute angle between these two lines. So the direction vectors we need to look at. So we can see, for instance, in this one, the direction vector was -3, 1, 5. So that's where this one comes from. This is the direction vector from the first example. And then to find the angle between them, we're going to have to use the dot product. So the dot product, remember, is going to be the modulus of A multiplied by the modulus of B times the cosine of the angle between them. In this instance, we're asked to find the acute angle between them. So we're going to find the dot product using the formula here. So -1 times -3, 3 times 1, -1 times 5. Add each of those together. That's going to equal the modulus of the direction vectors. So here 1 squared plus 3 squared plus 1 squared is going to give us 11. If we square these up and add them together, that's going to give us 35. So we need to take the square root of both of those, and we can rearrange for cos theta, which gives us a value of gives us a value of theta of 87.1.